Hey sir, I'm going to help you out with linear approximations. So I'm going to get started immediately. For this example, I'm going to use radical 101. So radical 101 is close to radical 100. Radical 100 equals 10. Radical 101, we do not know what it is. So we'll get this done. So basically, that's going to be our point. So consider everything underneath the radical to be an x. So then we have a point. We'll call it 110. So we'll be using that later. So from here we'll find the derivative of the function. So the function's derivative is going to be, well, let's start with the original function. The original function looks like this. So when we find, oh, we don't want that. So that's the original function. So when we find the derivative, it's going to look like this. So then from there, we can plug in this nice point of 100, easily solve. So from there, we get an answer of 120. And that is our slope of the original function at that given point. So then we have this slope over here, and then we have a point over here. From there, we can then create a line. So y minus 10 equals 1/20th. Parentheses x minus 100. Or we're going to just simplify this correctly. You don't have to distribute this at all. So let's give it plus 10. And then plus this whole entire chunk here, which I'm too lazy to write. From there, then we can plug in the original point, which was, what was it? It was 11. Oh wait, the original point for x1 was 101. So we'll just plug it in right there. Plus 1/20th. So x becomes 101 minus 100. So after all this, we get y equals 10.05. So that's our approximation. When we look at the actual value of radical 101, when we look at the actual radical of 101, let me grab my calculator real quick. So the actual value of radical 101 is 10.049887, and so on. So we notice this value is extremely close to our approximation, and yeah, that's linear approximations. Basically, for any value, we try to produce a point, we produce a slope, and then using the slope and the point, we create a line. We move it, shift all the values so the y is by itself. Then we plug in the original value from the equation, and then we get our approximation value, and that's pretty much it. Hopefully I didn't bore you to death and you can read my handwriting, and that's all. Good luck.